Logic circuits are basically in your second assignment, third assignment, and your exam. I know it's something from 11 marks, maybe we can say 9 marks up until 19, right? So, and before we jump into logic circuits, we need to first understand logic gates, right? Logic gates. So there are three most important gates, which is basically your AND gate, then we have the OR gate, right? And then we have the inverter. This is the OR gate, and then this is the inverter. So it's very important to understand how these gates work. This is the building blocks of any logic circuit, is the gates, right? We said this is the AND, and then this one is the OR, and then this one is the inverter or NOT. Some people call it the NOT gate. So for us to understand how an AND gate works, we first need to know the truth table. This is the truth table. So this will be input. For example, this is a 2-input AND gate. This is input A, and then this is input B, right? And then the output is A, B, right? A, B. It's something like multiplication here. So it's just AB. Then here, the input is A. Okay. Then this is B. So the output will be A or B, right? A or B. So we represent it by this plus. So this is A or B. Then for the NOT, if the input is A, the output will be A naught, basically the complement. So if the input is 0, the output will be 1. If the input is 1, the output will be 0. So the truth table of an AND gate, if we have two variables, A, B, and the output X, on the truth table, this is 0, 0, right? This is 0, 1. This is 1, 0. And then this is 1, 1. So an AND gate says, an AND gate only works if both inputs are high, the output will be high. So if it's 0, 0, low, low, the output is 0, right? 0, 1, 0, 1, the output is 0, right? 1, 0, 1, 0, the output is 0. When both inputs are high, the output is 1. This is basically the truth table for an AND gate, right? So here, the truth table for the OR gate, I know we did this last week. Truth table, if we have A, B, just use a different color. So this is 0, 0, 0, 1, 1, 0, 1, 1, right? AB, so this will be 0 or 0 is 0. So for the OR gate, if one of the inputs is high, the output will be high, right? 0, 1, this will be a 1. 1, 0, this will be a 1. 1, 1, this will be a 1, right? So the difference here is that AND gate, both inputs are to be high for the output to be high. OR gate, one of the inputs must be high for the output to be high, right? And then NOT, we don't need a truth table for this one. NOT, we know if it's a 0, the output will be 1. That's it, right? Okay, so now let's start with basic examples here. So guys, it doesn't matter. A is a variable, right? A is a variable. So this is a 2 input. Let's do this. This is basically a 2 input OR gate, right? 2 input OR gate. So here we can say A, B, and you know this is A plus B, right? A or B. My point is, it doesn't matter what this variable is. Remember, a variable is like a placeholder. It's like, for example, when you're programming, for example, you will say string name is equals to, right? So you see, this name is a variable. Because name can contain, it can be my name, it can be Caroline, it can be Ntabise, it can be Michael, get my point. So name is a variable. So even this A is a variable. Why am I saying that? I'm saying that because you won't get the logic circuit with A or B. You will get the logic circuit with, for example, WX plus YZ, right? So now it means that even if there is WX here, yeah, this one is fine. WX, WX, and then this is YZ. The output here will be WX. So we see this whole thing as A, right? The output will be this whole thing or this thing. Basically this whole thing plus this thing, right? So that's what I'm saying. This is just a variable. You just in this variable, you OR it with this variable here. Sorry, this is YZ. Are you guys with me? Any questions before we do the question?
Not yet.
All right, perfect. Okay. So now let's say I need to copy this again. So you guys are in phase 3 and phase 4. Let's see what we have here. Okay, so in the exam, in the assignment, this will be the question, right? It won't be as easy as what we're doing. So now you will see you have, for your input, you have W, X, Y, Z. This is the same as A, B, C, D, right? W, X, Y, Z, W, X, Y, Z, W, X, Y, Z, W, Y, Z, W, Y, Z. So it means how many variables do we have? 4, right? So we're going to have 4 inputs. 4 inputs. I want you to draw this line, right? Guys, this is basically your conductor. Even if you were to do practicals using a breadboard and this gate, right? You need to make sure that they conduct like a breadboard actually is structured this way. So you need to make sure that you're gonna place, for example, you'll see what we do now. Your W, you're gonna connect it here, your X, you're gonna connect it here, your Y here, your Z here. So I need you guys to do this so that you don't have a lot of inputs, right? Then this is your W, this is your X, this is your Y, this is your Z. So these are all our inputs, W, X, Y, right? So now we need to construct this gate. You see this gate, we need to take this W, which is A, for example, and X and Y and Z, and make a gate out of this. So which gate is this? It's our basic AND gate, right? It took this input and then it just basically almost multiplied this, right? So this is the same here. So now to build this gate, now we conduct, right? W, X, Y, Z. But now we know this is an AND gate, but now W is inverted. There's a complement there, right? So which gate is that? It's this one. For example, W not. So we need to invert all of this to get this output, right? So we invert with a NOT gate or inverter. All right, so these are 4 input AND gate. So then we take this, these are all inputs into this AND gate of ours. Great stuff. So we find here we have this one, right? So now the second one, W, Y, Z. Oh, sorry, this is X. W, X, Y, Z, right? So let's do the second one. We need to conduct everything again. W, we need X, Y, and Z. So we have all our variables. Now let's see which ones must we complement. W, it's fine like this. We're going to take it as it is into our gate, right? X, it's fine. We're going to take it as it is into our gate. It's going to become an input into this AND gate, right? And then the other one, Y, not. So we need to invert the Y. Then we take it into our gate. Then Z, not. Going to invert the Z. Then we also take it into our gate. So this is basically W, X, Y not, Z not. Here is. So we have this expression here. Okay. So now let's go to this one. What is this one? Is it not as well? Let's see. Let's just see from the question paper. Okay, let's remove it. Yeah, I see I canceled this out. Let's remove it because if we keep it, it's going to be the same as the first one that we did, right? So now let's say this is basically W naught, X naught, and Y naught, right? Okay. W naught, X naught, and Y naught. So we cancel in this one, right? Because it's gonna be the same as this one if we complement this set. So now what do we do? So we know we have 4 inputs again. W, X, Y, Z, right? So we're going to take W, we're going to take X, we're going to take Y, we're going to take Z. W, X, Y, Z. Yeah. And then W, X, Y should be complemented. So we need to use the inverter, right? For these 3 inputs. All right. And then Z, we take it as it is. So these are inputs into a 4 input AND gate. For input AND gate. All right. So now we are here, right? So here, what do we have? We have W, X, Y, Z. W complemented and Y complemented. Yeah, this I think will probably be close to 19 marks. Okay. W, X, Y, Z. W, X, Y, Z. Now let's check which one is complemented. W is complemented and Y is complemented. W naught. X goes, it's fine. It needs to go like this. Y is complemented. So we need an inverter here. And then Z goes as it is. So here's our 4 input and gate again. Great stuff. So now the last one is WX. It's only 2. Do you see that? WX. Remember, W is the first one, X, Y, Z, right? So we need the first 2 here. W, X. We saw that it's an AND gate. So this is a 2 input AND gate. And then we have the YZ, right? YZ. 2 input. 2 input AND gate. Great stuff. So we have everything here. Now, let's combine this. We need to combine this and this. Do you see that? So this variable, remember why I was using this example of name, right? Say name is a variable. I said A is a variable. It doesn't matter. This it's a holder. It just allocates memory for anything that you're going to pass, right? So in this case, what are you passing? What is your A? Your A in this case is WXYZ, right? Which is this whole thing, this whole gate here. That's your first input. Then this is your second input, right? Which is this gate. So these are A and B, for example, A and B into a AND gate, right? So the one that multiplies, the one that uses brackets, is a AND gate. So we take this 2, put it into an AND gate, 2 input AND gate. Great. Now we need to take this one and this one, right? We need to take this one and this one, then we're going to add it obviously with this, right? So let's take this one and this one. So it's basically this gate and this gate into a AND gate. So pretend this is A and this is B, right? So we just take in this 2 into an AND gate. Okay, so we took this 2. Now we have your WX. Here's our WX, and then your YZ. Okay. So now let's do it properly. Now this 2. Now we're going to use the OR gates now. This 2, right, which is this 2, the output here, it needs to be ORed with this 2, the output of this thing. So they need to go into an OR gate, right? Need to go into an OR gate. Even this one needs to go into an OR gate. So that gate is going to plus, and then it's going to plus this. Now that gate also pluses this, WX plus YZ, right? Do you see that? So you can take this as well. I see there are two ways. I think one student wanted to do it this way. This way is actually the correct way. This OR gate. If you're working for a company as a designer, uh, as an what is it, electrician, this is the best way because you want to save the number of gates that you use. So we just took this one input, second input, third input, and fourth input, right? We took everything 1, 2, 3, 4, right? So we had 4 inputs. So our output is F, which consists of all these things. Another way that I always do, I always take this two. I was gonna take this two, this end, right? And then this one, and then make a 2 input OR gate here, 2 input OR gate to do this too. Then after that, I was going to bring this WX into my 2 input OR gate and then this YX. But anyway, I would be using an extra gate. Do you understand? So this is the cheapest way to do this circuit. Remember, you always want to use as little gate as possible. They deem a gate as an expense, right? So now your circuit, you will see when you simplify, you only simplify so that you reduce the number of transistors that you are using in the circuit. Okay. Any questions regarding this one? No questions.